Hello and welcome to my channel. So today let's look at a daily challenging question 797 all paths from source to target. So given a DAG of n nodes labeled from 0 to n minus 1, find all possible paths from node 0 to node n minus 1 and return them in any order. The graph is given as follows. Graph I is a list of all nodes you can visit from node I. So first graph given and the output is 0, 1, 3, 0, 2, 3 because there is only two paths from 0 to 3. Similarly, and the time complex the constraint is n is between 2 and 15. So it actually gives a hint that this is like using brute force search. So all the elements are unique. The input graph is guaranteed to be a DAG, which is directed acyclic graph. There's no cycle in the graph. So the approach, we can use the depth first search or DFS to do this, and the time complexity will be, because there will be totally about 2 to the power of n path, and we need to go through each path. So it's the time complexity is n times 2 to the power of n, and the space is so if we space is will be the depth of recursion we do. So because we are using the DFS, and so it will go through all the possibilities. It will be about like ON, I think. I mean, this is the extra space, not counting the answers, like the answer array or list. So let's work on the question. So firstly, we can define this paths. Then we can define the we can also define a path which is the current path. Then we add a 0 to that because we are starting from 0. Then we do the DFS. We have the starting point, then graph, and the path. So then we need to define this DFS. So we can have and list path. So firstly, if the S is n minus 1, then which means we already found the path. Then we can add. So here we need to make a copy of this path. So and then we return. This is the ending one. Then we can do the next graph S. So which is the next so then we add the next to the path. We do the DFS on the next graph path. Then we need to do the backtracking to remove the next, because we are not following this route. Then Yeah, so this is basically the code. We just return the path in the end. Oh, yeah, we need to define the end. So end will be path dot length, a graph dot length. Yep. Yeah, so this conclude the today's daily challenge question. It's this one is a simple application of depth first search (DFS). So thank you for